Surface area and volume of cells. The larger the volume of a cell, the more food it needs. If you picture two cells, the one on the left would contain much fewer hungry mitochondria than the one on the right. The one on the right would have to take in much more glucose to run cellular respiration and survive. So how are the cells going to let that glucose in? Using their surface area, represented by their membrane. Membranes control what goes in and out of cells. For example, these membranes might have protein channels, allow the glucose molecules in to the mitochondria that need them. So which cell is going to have an easier time feeding itself? This one has an advantage because it doesn't need as much food, while this one has an advantage because it has more protein channels to let things in. So which cell wins efficiency-wise? The answer lies in the ratio of surface area to volume. Volume represents the amount of food needed, and the surface area represents how quickly the cell can get it. The higher this ratio, the more surface area the cell will have to feed its volume, and the more efficient the cell will be. Knowing this, which of the following cells would be the most efficient? Let's say one cell has dimension of 5 micrometers by 1 micrometer by 3 micrometers. Another cell with dimensions 4 micrometers by 4 micrometers by 2 micrometers. To help us visualize the comparison, I often draw pictures. There's my 5 by 1 by 3 cell, and there's my 4 by 4 by 2 cell. Pause the video for a moment and see if you can calculate which one is more efficient. So first, let's calculate the surface area for each cell. This top surface is 3 by 5, which is a total of 15 micrometers squared. This side is 1 by 3, for a total of 3 micrometers squared. And this side is 5 micrometers squared. Hidden from view are 3 other sides with just the same length. This one in the back, this one on the side, and one that's on the bottom. We can take this total and multiply it by 2 for a total surface area of 56 micrometers squared. Meanwhile, the top of this prism has a 4 by 4 or 16 micrometers squared surface. This side has 8, as does this side. Multiply by 2 for the back sides and the bottom, and you have a surface area of 64 micrometers squared. So far, it looks like this cell is winning because it has a larger surface area to feed itself than this cell does. However, how much volume do they have to feed? Volume is calculated by multiplying length times width times height, which gives us a total of 15 micrometers cubed here, whereas here, 4 times 4 times 2 equals 16 times 2, 32 micrometers cubed. So the ratio of surface area to volume in each case is different. For this cell, it's 56 to 15, which is very close to 4 to 1, while for this cell, it's 64 to 32, which is exactly 2 to 1. This cell has the greater surface area to volume ratio, meaning it will have an easier time feeding this volume with its relatively large surface area, while as this one, though it has a slightly larger surface area, can't feed this huge volume. Therefore, this cell, with a smaller surface area to volume ratio, is less efficient than this cell. This means that, as a rule, smaller cells usually are much more efficient than larger cells because the surface area to volume ratio in these cases is much greater than the surface area to volume ratio in these. Furthermore, as we'll learn later in biology class, in some systems, cells will grow very irregular shapes to increase their surface area, so they have much more of it to help feed their volume. So stay tuned for strangely shaped cells and other structures.